Hello everyone. So in the previous session, we were doing the modeling part of our retail project, and we have used linear regression. As per the discussion, we talked about requirements for applying a data into a model, and linear regression requires data to be normally distributed. There should not be any correlation or collinearity among the features, and then you can put up the data into the model. In case the features are not normally distributed, then you have to apply transformation, and we did applied log transformation. For that, we have to check that anything in log should not be come as 0 or negative. So we also seen a code where we corrected this requirement to put the data into the model. As you are seeing currently, that in our data features there are certain features which are having the negative values, so we turn up them into positive ones, and then we found corresponding value for that, and then we have put into the regression model. Okay. Meanwhile, there are few more things important. Specifically, we discussed related to one hot encoding, because it's a technique for creating the dummies into the data. The reason is we are having your suppliers and the item type, which are categorical in nature, so they needs to be converted into one hot, so that we can put into the model and proceed ahead for the rest of the analysis. Okay. R2 score, that is variance explanation, we also discussed related to it. What is R2? R2 is something which is required to see whether the predicted points which you have calculated, and you are having an actual line, the real line, how much of them are being better fitted into it, because the goal of linear regression is to find the best fit line. Okay. If the majority of the predicted points are explaining the variance or explaining the actual line, or they are coming on the actual line, that means okay, the line is good to best fit. And if they are not, so in that particular case R2 score will be less. That means below average. For example, till point 0.5 it is average, and below point 0.5 is like below average. Okay, so it's point 0.2, point 0.3, something like that. It's a below average variance explanation. We are having two things for the analysis. We are having error also, and we are having R2 score also. Okay, two things we are having. Error, that means how far the points are away from the actual line. That's an error. And R2 is the variance explanation. We expect that both of these terms should have to be good. If error is less, okay, that means points are closer to the line. That's what we have achieved. You can see the error in case of linear regression. We got it as like 2.29 into 10 to the power minus 5. Okay, it's very less error. That means points are just present near to the line. Okay, and that means they are giving the predictions which are closer to the actual ones. However, they are not been so much present exactly on the line. Okay, so we are having 30% variance explained. However, the points are nearby, they are distributed nearby. So we are having some error, very less error, but not that much high R2 score. But still, we'll say that the model is good. Okay, then there is a question arise related to adjusted R2 also, that can we adjust the R2 score. Okay, so this is a formula for adjustment of the R2 score, where this is your shape. Now that means the number of rows in the X test. This is the number of columns in the X test. Shape 0 means rows. Shape 1 means columns. So this is a row and this is column. Okay, and the adjusted R2 score, the formula is this thing, 1 minus 1 minus r2 into n minus 1 divided by n minus p minus 1. Okay, fine. And we calculated r2 also, adjusted. That means if there is an issue related to the explanation of the variance, we can try this particular formula to find the adjusted r2. The whole deal is related to the explanation of variance only. Okay, how much your predictions are explaining about your the desired the outcome which it needs to be. Okay, so I calculated adjusted also, and that's like this thing. This is r2 and this is adjusted r2. Both are just like very closer ones, not so much difference in them. So yesterday, means in the previous session, there was a question asked, sir, you are having one hot encoding, so many features are there. This might be a reason that variance is not properly explained. What could be a possibility? So I think let's include this part of code also and check, is there any change in the variance explanation. But I found that there is no specific change. Okay, one more question related to the regularization. That means if we have done one hot encoding, so many features has been built. So because of the so many features are there, we have to apply the regularization. That means can we drop some of the features which are not at all giving the good result to the model? That means they are not at all contributing for the model development. So regularization, I use one regularization technique, that is rich. Okay, we are having on that particular class also, I told we are having two techniques like lasso and the ridge regularization. We can use combined also, and the name is elastic net. Okay, so we are having L1 L2, and we can combine L1 L2 also, L1 plus L2. Okay, so in this particular case I have used L2, that is the ridge regression. Okay, and that's also a part of a linear model, like linear regression only, it's a part of a linear model. Okay, however, it's a kind of a penalty. Okay, it's a kind of a penalty. Okay, so let me share my entire screen now and let me talk more about it. In case if your model overfits, okay, if your model shows overfitting, so we have to impose penalty over the model. Okay, for overfitting, we impose penalty over the model. Okay, so at the moment we are having two penalties and it's acceptable in deep learning also, L1 and L2. Okay, fine. So L2 is the penalty which I am using currently. L1 also I use, but it gave me absolutely wrong result. It gave me negative R2 score, and negative R2 score is not at all like, that means it's a wrong model. Your model is totally failed. Okay, so I use L1 also, but I ignored that particular code. I use L2 then. L2 is giving me like such kind of score. You can see it's giving me a score of like 0.29 for R2, and mean square error is just like as model only, linear model only. That means there is no much gap. Also also the kind of penalty which I am trying to impose here is very less, 0.001. You can change the penalty figure also. I tried with zero point 0.1, I tried with 1. Okay, but there is too much compromise in the result. Okay, so whatever we have done in linear regression, I think that's fine. Also, the one thing which can we can mark here is data. Why such things are happening? Because of data. We are having very less features present in the data. Okay, very less features present. And if you're trying that your model should give very perfect result, okay, that is something difficult to happen, because everything depends upon data, what is available with you. Okay, if you're not having the good part of the data, if you're not having so much information present in the data, and if you do expect that applying a algorithm, applying a technique over such kind of data, you're getting high scores, it's not feasible. In fact, you can do feature engineering. I did included the feature engineering stuff also. Okay, but again, I need to check whether they are not showing the correlation. Okay, so as per the demand, I included ridge regression also. Then this is the plot for ridge regression, that's quite similar to like linear model only, linear regression only. Okay, fine. um, then I have used these models like all the rest of the regressors: SVR, decision tree, random forest, XGBoost regressors. Okay, all I have been used. Okay, and then what we got in the result as, okay, these are the results which we got after using the regressors. Okay, rest of the regressors. That means in SVR only 9% of the variance is explained. Dysentery actually failed, negative R2. Dysentery failed to explain the variance. Random forest and XGBoost did explained good variance, that is 34 and the 24% of the variance explained. This is MAE, mean absolute error. Above, in case of linear regression, and the which I calculated MSC, mean square error, MSC, MSE. Okay, what is the error? Error is y dash minus y, that is predicted minus actual. This is error. Absolute error means mod of this. Okay, so error calculation is the way to do the analysis in the data. Error calculation only. This is how we do perform the model evaluation. So as a error calculation is everything. Okay, so we can have either MAE, either we can have MSE, either we can have RMSE. These are the errors: mean absolute error, mean square error, root mean square error. In general, we do prefer MSC, mean square error. Okay. However, in case if the value of MSC is more, then we can apply the root of MSC. That is root mean square error. Also, if you are having outliers present in the data and MSC is more, we have a chance to apply MAE also. That is mean absolute error. Okay, so at this particular stage, I have used MAE. However, you can calculate RMSC, MSC also. Okay, so this is the regression models or regression algorithms I have used. Okay, fine. Yes, Subhashish. Any doubt, please? Okay, any doubt, please let me know. Okay, fine.
Hello.
Yes, Subhashish.
Yeah, yeah. So, what I have heard that means from most of the people that means the MAE and MSC has a different application based on the conditions,
Different.
right?
Yes.
That means because yes, yes, because the MAE is not differentiable for that means at some point,
See, differentiation is
but
an issue,
MSC is a
Subhashish. Differentiation ही issue है. देखिए क्या है कि you are applying what absolute value. So differentiating an absolute value is a complicated task. You know how we can do that particular thing. If I say y dash minus y, okay, and if I want to differentiate it, ठीक है, with any of the parameter, either by m, either by your b. Okay, because you know that we have to optimize error and we have to differentiate the cost function or with the parameter. Okay, that's what we have to do. Fine. So MAE is not preferred. Instead, MSE is preferred. That means what is the square? That is the square of the error. So if I can differentiate, I can get 2y dash minus y, and all these things we can do. Okay, fine. That's what we can perform. Okay, so MAE is just like you calculate y dash minus y, that is an absolute error. Okay, and also we are going to use MAE in that particular case, that when you are having what, MSE more, MSC is more, mean square error is more. That means you are having presence of outliers in the data, due to which error is coming more, because here the square of the error is calculated. For example, if the value is 2 of the error, if you calculate square, it will become 4. Okay, so if there are more outliers, outliers are present very much far away from the line. Okay, for example, this is your actual line and this is one of the point which is present. And if you calculate the error, this is the error. And if you square it, so that will be much more high value. Okay, so we are not preferring MS in this particular case. So if you are having outliers, ignore MSC. You first try with RMSC. If this value is less, okay, else you can go ahead with MAE. And differentiation, as you told, Differentiating this mod value is like complicated. We don't prefer the differentiation in this particular aspect. Okay, yes, Subhashish.
Yes, yes, fine.
All right, fine. So that's the case. All right, and then I proceeded ahead. These are some feature engineering. Either you can create sales ratio, either you can create sales difference also. These two features which you can create additional in the data. Okay. However, ultimately, sales ratio will be again dependent upon retail sales and the warehouses because they are created by these features only. Okay, so there will be dependency correlation can be obtained. Okay. However, these are present in the code. You can find these and you can apply regression on DF2 using now new data frame with these features present. Try to find the correlation first and then you can do it. Okay, fine. Then I applied unsupervised learning also. Okay, that was my linear regression and rest of the regression algorithms. Then I applied unsupervised learning also. That means I thought that don't consider any target. Okay, don't consider that warehouse sale is a target. Don't consider that retail sale is a target. No, don't do this thing. Just consider unsupervised learning where nothing is the target and just try to make a cluster. Just try to make a group. Okay, so here I imported first the PCA, that is a principal component analysis. I hope you are aware of the PCA algorithm, principal component analysis, very important algorithm. That is called as a dimensionality reduction technique. Okay, that's a dimensionality reduction. Okay, in unsupervised machine learning. Fine. So that I have imported at the moment, and these are the features available with me. Again, I'm going to take the same features. That means year, month, supplier, item type, retail sales, and the warehouse sales. All these now I am considering. Fine. And then what I'm doing next is the same task which I did above. That is one hot encoding of the categorical and standard scalar for the numerical column. That's what I'm doing. Okay, fine. And then I gave this data into the pipelining so that my above code will get execute and my matter will be solved for that. So my data will be now processed data. Okay, this processed data, as you know, that there are so many like suppliers and item types. So obviously my data frame is now a sparse data. That will be a sparse matrix. Okay, with 301 columns. Okay, 301 columns will be there and 30,000 rows will be there. Okay, so that my data is a sparse data actually after performing this activity. Okay, however, anyways, I need to perform unsupervised. Okay, unsupervised, and I need to cluster my data. Okay, that's what I want to do. Perform clustering. For clustering, I am looking forward to use k-means algorithm. Okay, which is a famous clustering algorithm. Okay, so I mean to group the data. Okay, that can be like cluster A, cluster B. My goal is to perform the grouping in the data. Okay, fine. So here I am importing k-means as the algorithm. Okay, k-means algorithm. Fine. And let us suppose, I hope you have a knowledge about this thing, that from 1 to 11, range 1 to 11, that means I'm going to identify 1 to 10 clusters. Okay, 1 to 10 clusters in the data, and whichever be the best cluster, that will be finalized. So I am applying or I am using elbow method. Okay, I will run the k-means algorithm over the data. Okay, and I will put, okay, first one cluster will be there, then two cluster will be there, then three cluster, and so on till 10 clusters. Okay, and I will check that at which particular point I am getting an elbow like this. So that will be the number of optimal clusters present in the data. That's what I'm looking forward for. Okay, so here I applied the k-means clustering algorithm. Okay, I fit my data, X process the data into k-means algorithm. I'm taking one cluster, two cluster, three cluster with the help of a loop. Okay, and you very well know that on X axis I am having number of clusters, and on Y axis I am having WCSS. That means within cluster sum square. Okay, that means the cluster center and the distance of the data points square sum of the distance of a data points from the cluster center, that is called as WCSS, within cluster sum square. Okay, so I did apply this thing, and here is what I plotted for the elbow method. This is the plot for elbow method. Now you can see, where do you think that we are having optimal number of cluster? I can see that here there is a bend at two clusters there is a bend. Also at 7 I can see that there is a bend. That means either 2 or either 7 clusters could be optimal clusters present in the data. That means I can divide my entire data. That means I can divide my entire X processed data into two parts. Okay, that is possible. That means I can create two groups of my data. Okay, fine. So it will be certainly like this. Okay, K means this cluster don't overlap. Okay, they don't overlap in K means. So I can have two separate clusters. That is what I found by the K means right now. Two optimal or either 7. There's also bend in the 7. However, I'm preferring 2 at the moment. Okay, fine. So here, okay, here, after finding that what are the optimal number of clusters, I put the value number of clusters equal to 2 in K means. Okay, and found that 0 and 1, there are the two clusters present. I added this cluster into my data frame. Okay, df1 cluster equal to clusters, I added them into my data frame. Okay, and here I printed my data frame. I found that okay, yes, there are two unique values of cluster 0 and 1 because we have divided the data into two parts. And I found the value. What is the value count? So it's like 29,000 are coming in one group only. The rest, very, very minimum, 38, they are in cluster 1. That means only 38 points are in cluster 1. Rest all 29,000 are in cluster 0. This is what I'm getting. Okay, so very unfair kind of distribution. However, because it's data related to the retail, so unsupervised is something because it's kind of a data related to sales. So unsupervised is something which we got a chance to apply, and we did apply it here. We got two cluster as an optimal, and when we found that how many data points are following which cluster, so 99% are following cluster number 0, only 1% is following cluster number 1. That's what we are getting. Either I can do one thing, 7 cluster is also an option, that is also one of the optimal. I haven't tried in this particular code, but you can do that. Put 7 also in this particular. Here you can put 7 number of cluster equal to 7, and then try to find what are the unique values, how the distribution goes. At the moment I did with 2. Okay, one more thing, it came into my mind that okay, I am having this X processed data as a sparse. Already I mentioned, while printing the X process, it told that okay, you are having a sparse matrix, you are having a sparse data, so most of them are 0. What can I do with that? Is there any solution? So the solution lies in compressing the sparse data. Here is the solution lies. So I use one library that is called as SciPy sparse import CSR matrix. That's what you can do. Okay. So okay. So very important step. And there are other techniques also to solve such kind of problem of sparsing. Either you can use in above code only I've used PCA. There is one more algorithm that is called as SVD, singular value decomposition, very important. And in LLMs, large language models, okay, they do apply such kind of techniques to like minimize the weights, okay, so that the computational complexity will be reduced. Since our data is having so much sparse representation, I'm going to apply this CSR. Okay, so the CSR format is optimized for row based operation where memory efficiency, that means it only store non-zero elements of the matrix. Zero will be tata bye bye. Okay, that will happen. That means it will reconstruct the matrix structure, and non-zero will be given the preference. Zero will be because what outcome I'm going to get from the zero. Okay, so this is the case with the CSR matrix. All right. So what I did, I gave X processed, okay, to convert it into CSR matrix. Okay, fine. That's what I gave here, and this is X processed now. That means now I'm in consideration with the relevant values, relevant rows, which are having less number of zeros. Okay, I converted it into a data frame. This is my data frame for X processed. Okay, actually it was an array. After processing, we converted that into array. We can create a data frame also for X processed like this. Okay, this is a data frame. Okay, still I am having 301 columns, 30,000 rows available to us. This much we are having, 30,000 rows and 301 columns. Okay, so what I found that we tried to apply the technique of CSR to reduce the sparsity in the data. Okay, as per the definition says, memory efficient, faster arithmetic operation. Okay, ultimately it's an optimization technique. Okay, that means it's an optimization for row based operation. It only store non-zero elements of a matrix along with indexing information. So we do create a CSR matrix that will be having what? Only relevant. So I haven't printed the CSR. Okay, control C. Okay, let me print this CSR also. Okay, let me check out here CSR matrix. Okay, this is also sparse matrix, SciPy sparse matrix. That means it has covered those which are been which are been relevant rows, less number of zeros. Still we do have like sparsity, some amount of sparsity is present. Okay, at the end, what I did is I applied PCA, principal component analysis. That means I selected two components or two major informations which can be extracted from the data. Principal component analysis is a technique which creates principal components, PCs, which can create the PCs, principal components. For example, this is your data distribution. This is your data distribution. And if you are having feature 1 and feature 2, you can't drop any of the feature because both are linearly dependent. Now, if you are having such kind of distribution, if this is your distribution, this is f1, this is f2, f2 is less than f1, but still it is having some percentage, you can't drop this one also. So it's better you have to align fn, f1 and f2 on principal components. PCs. You have to align them on principal components. Like if this is your axis, you create principal components. These are the principal components. Let us suppose this is PC1, this is PC2. So a feature which is showing maximum information will be covered on the principal component. Okay, will be covered on principal component, and the feature which is having less information, we got a flexibility to drop it. Okay, so for example, a feature which is showing more information, let us suppose it is present here. Okay, it is present here. Fine. And the feature which is showing less information, okay, we are also capturing it in the PC principal component, but because you have changed the orientation here. So previously, if it was giving 20% information, because of principal component, now it is turned up to only 4%. That's how you have changed this orientation, by creating the principal components, and you have put the data on the principal components. Okay, so principal component, those features which are having less information, but still they are having a kind of information like 10% or 20%, and we are not able to drop them. Okay, so let's use the principal component analysis and then apply it here. Okay, and then you can finalize your result. So two components I have used here. Okay, number of components are two. Okay, so here you can see PCA1, PCA2, and I have plotted the cluster on them. Okay, so two components took, and here I drawn the cluster on them. Okay, so this is second component, this is the first component, and these are the points. This is cluster number one, and this is cluster number two. Two cluster, one is blue, one is yellow. So whatever be the data points now which are present in my this X processed, I have done the principal component analysis, I have applied the PCA, and I have created only two columns and converted that into a data frame. Okay, so I will be having a new data frame that is having the two columns, only two high information columns. Okay, only those features which are giving the highest information are now available with me, along with in which cluster they are present. So only that I am considering, and this is what I got. I plotted them. So principal component analysis is a dimensionality reduction technique. We are having 300 dimensions present in the data. 301 dimensions. We know that not every dimension, not every feature is giving information. So it's better to drop them, or either it's better that consider only those features which are giving highest information. For that, PCA is a better technique. There is one more technique, that is SVD, singular value decomposition. It has also been applied in most of the cases. Okay, however, I just go ahead with the PCA. I did apply the PCA. So two components I took, two features I took. Okay, which are giving the highest information. Okay, and then I made cluster, in which cluster they are present. So here is the plotting. Here I plotted in which cluster they are present. I plotted. So two clusters. Okay, fine. One is the blue, one is the yellow. These two cluster I'm getting. Okay, fine. So what approach we did in this unsupervised learning? What we did? See, we are already available with the features DF1. We are already having all these features like supplier, item, retail price, warehouse price, etc. etc. We are having present. Very less what we are having all these data. I want to make a group of them. Okay, I want to perform a grouping. Okay, that is what I said is a clustering. So I applied the k means and I got the cluster. How many optimal clusters I am having? I could have ended up here only. Once I got the cluster, I add the cluster in the data frame. That's it for me. But still, in order to plot those clusters, in order to do plotting, PCA is something which is mandatory. If I don't apply the PCA, and if I take the entire X processed, and if I, yes, I can make the plot with entire X process also, but it will not show relevant. It's better to apply the PCA. PCA will help you in identifying those features where highest information is present, highest info is present. Okay, so I took two components. Okay, it depends because PCA na what it do, PCA arrange all the features in descending order. This is what PCA do. Highest information, then lower, then lower, then lower, then lower, then lower, and so on. This is how it arrange the features. So I took these two, which are showing the highest information, and I plotted them. I plotted them. Okay, and this is cluster number one, and this is cluster number two. This is what I got. So I applied unsupervised also on my data. Okay, then comes a different technique, association. One more approach I applied, that is association. See, association, like, okay, in unsupervised, you are having clustering and association. Two things you are having, clustering and association. Clustering is one I applied. Yes, Madhu?
Sir.
Hmm.
So, what would be the metric for this clustering here? K means.
We can use the metric for the clustering. Like
Hmm.
if you want to evaluate this K means, so you are having sellout score. There are two to three other scores which can be calculated whether the clusters you have made are proper or not. Okay, and the metric will be like this thing only because the dependency upon the clusters, that how much far they are. If the cluster are very much far away from each other, that means your clustering is successful. And if they are closer to each other, that means obviously you are having data outlier present, and that might be a reason that clusters are showing very closer to each other. So sellout score I will suggest. Okay, and that's what been used in most of the cases as a metric to
Hmm.
evaluate a clustering algorithm.
Okay. What about this DB scan? Usually, DB scan,
Density
I.
based scanning, if you are saying that, yes, we can apply density based scanning also. That is also one of the clustering. We can apply hierarchical clustering also. That is feasible. Hierarchical clustering, DB scan, density based scanning. We can apply all these techniques. Okay.
Hmm.
Yes, you can do that. However, see, there are drawback and advantages of each and every algorithm. The drawback of K-means algorithm is here you have to give predefined the number of clusters needs to be made. That is a drawback of K-means. However, I have applied elbow method. Okay, I have applied
Hmm.
elbow method to
Hmm. Hmm.
identify that what could be the optimal feature. So in K-means you have to primary give the value how many clusters needs to be made. In DB scan you do not have to give how many needs to be made, but there are other features. That means other parameters which needs to be applied in the DB scan. Okay, like what should be the length of the radius? I don't know whether other people have a knowledge about density based scanning, but there are two parameters need to be given in the DB scan. Here in KMIS, only one parameter we have to give. That is the number of clusters. In DB scan, it requires two parameters to be known. That is why we try to exempt such kind of algorithms. Okay, so they are
Okay.
na in density. We do make the circle. Okay, that means we
Hmm.
do randomly select a data point and we make a radius and try to find the density, that how many points are coming in that particular range. So that circle, that radius value, we have to just select randomly what it should be. Okay, so here we are having one parameter and there we are having two parameters to adjust. Okay, got it. So DB scan I'm not
Okay.
using, but you can try. Not to worry. If you are applying clustering, you are free to choose.
Okay. But the metric would be Shlout score.
Shroud score.
Okay. Okay,
Okay,
sir.
all right, fine. So this is how you can apply. Now, since I'm already using unsupervised, so I thought that why shouldn't I give a try with association? So, what is association actually? Association is again a relationship. Association is a relationship. Okay, and very less like people now do explore all these things. Okay, association and all. Okay, very less explore terms. Okay, I hope you have heard about this market basket analysis. Okay, market basket problem. Okay, market basket problem. That means if someone buys buys bread, what is the chance it's going to buy a milk? What is the chance it's going to buy a butter? Okay, so this is market basket problem association. Okay, so I thought that okay, I'm available with item type, I'm available with the suppliers. Can I find some frequent items which are buyed from the seller, something like that? Can I try so I can get some information related to it? So in that regards only, I have used association algorithm. Okay, association technique here in the code. Okay, and for association there are certain algorithms, some libraries which are mentioned, like a priori, association rules. Okay, transaction encoder for pre-processing. A priori and association rules are used to find the frequent patterns in the data. Okay, this is kind of a pattern. That's what I'm telling. This is a pattern. That means if someone is buying bread, what is the chance he or she can buy milk? What is the chance he or she can buy butter? What is the chance he or she can buy any other thing? So I just try to find the relationship, how these transactions are being done. That's the association rule. Okay, fine. So here in my coding part also, I included the notes for your convenience, that appropriate algorithm is used to identify the frequent item sets from the transaction data. Okay, so what is the transaction data? Now let me talk some more concept related things to it. Okay, association rule. Association is a powerful data analysis technique to identify the patterns or trends or relationship in a large data set, especially market basket analysis. So right now we are following market basket analysis only. Okay, and association rule. Association rule is a technique in data mining for discovering interesting relationship, frequent patterns, association, correlation among the variables in the data. Okay, so for example, you can see that, let us suppose this is the transaction done. That means some person went to a shop and he purchased milk, butter, and bread. So, first time he went to the shop and he purchased this thing. Second time he visited the shop and he purchased bread, diaper, beer. Third time he purchased milk, diaper, beer, and cola. Then fourth time he purchased bread, milk, diaper, and the beer. Then fifth time he purchased bread, milk, diaper, and the cola. Now the thing is, what we need to analyze is association. How these items purchased are related to each other. Okay, fine. So in this particular table, that is a transaction table for a customer purchase. Okay, we have to make set of items, that is called as an item set. That means collection of more or one or more items. We can make the set of these items. Okay, like we can make single, two, and three item sets. Single item set means just take the unique item set. Single. Two item, that means just take like this: bread, milk, bread, butter, diaper, beer, etc. I can make combination of two. Then later on, I can make combination of three also. So I can make the set of items. Okay, that's what I can do. And then I can apply association rules over them. That okay, you have considered a set of milk, bread, and butter, how they are correlated to each other. Am I purchasing milk, then I'm purchasing bread, then I'm purchasing butter, or not? Just try to find the association rule. Okay, so what happens is, association rule is a fundamental concept in data mining to reveal how items are connected to each other. Okay, and we use if then statement here in association. Okay, that means if this, then this. All right, for example, let's consider diapers, baby wipes. Okay, so this suggests that in a transaction where diapers are bought, strong likelihood that wipes are also purchased. Okay, so if diapers, then baby wipes. This is what association, this is what a rule is. And here is your market basket analysis. Okay, this is a customer number one, he purchased this thing. Customer number two, he purchased this thing. Customer number three, he purchased this thing, and so on. Okay, so market analysts now, they do try to find this relationship only. They try to find this association only over the data. Okay, so like this thing, bread and the milk, beer. Okay, components of association: bread, milk, purchasing. Is there a purchase of beer also? So it's called as antecedent, and this is called as consequent. Antecedent and consequent. This is antecedent. This is consequent. Okay, fine. So every association rule has two parts: antecedent, consequent. If, then. For example, pasta, sauce. Pasta is antecedent, sauce is consequent. Okay, and how to evaluate the association? For evaluation, you have to find support, confidence, and lift. This is the three ways you can evaluate the association rule: support, confidence, and the lift. Okay, so what is support? See, support is a measure how frequently item, that is both x and y, appears in the data set. Okay, appears in the data set, how frequently they are appearing. That means I am having in a transaction number one, milk and bread. In transaction number two, milk and bread. Transaction number three, milk and bread is there. Okay, so in all these transactions I am having, these are the total number of transactions. For example, out of 10 total, 7 I am having. In 7 transactions, I am having these two items. So the support is zero point 0.7. Okay, the value of support is zero point 0.7. Confidence is frequency of xy divided by frequency of x. That means how many times both are coming and how many times only x is coming. That is called as confidence. Okay, so what does confidence tells? It measures the likelihood of finding the consequence in transactions under the condition, but these transactions also contains antecedent. That means it's a rule. You're talking about bread and the butter. The confidence measure how often butter is bought when bread is bought. That is what the confidence is. How much confident that okay, someone is purchasing bread, will it purchase butter also? That is called as confidence. Okay, and then we are having a lift. Another lift measure, it tells how much often the antecedent and the consequence of the rule occur together than we could expect if they are statistically independent. What does it mean? This measure the strength of association between x and y. Association. I'm talking about what is the association, exact association between these two, exact relationship between these two. So the formula is support. Okay, that's what we have already calculated. Divided by support of x and support of y. Support of x means frequency of x. Support of y means frequency of y. That is called as a lift. So support, confidence, and lift. This is the way you can evaluate your association. Okay, fine. So let us take example. You are having bread and the milk. Okay, bread and the milk. So we can calculate the support. Like for example, these are the transactions where bread and the milk both are coming. In T1 it is coming, in T4 it is coming, in T5 it is coming. Okay, so out of 5 transactions, 3 times bread and the bread and the milk are coming together. Okay, so the support will be 3 by 5. That is equal to zero point 0.6. That is zero point 0.6. Confidence is the number of transactions with both bread and the milk divided by the number of transactions of bread. So how many times bread appeared? For example, bread appeared 4 times in total, and 3 times these two came together, bread and the milk. So 3 by 4. Okay, so the answer is like 0.75%. This is the confidence. That means if I'm purchasing milk, 75% there is a chance that I'm going to purchase bread also. This is called as confidence. Okay, so there are certain examples which are mentioned here with me. I can share the notes also. These notes I can share. Fine. And there are so many applications of association rules. Like market basket is one of the application. Here we are dealing with the retail also. So that is one of the preferred example which we can say. Okay, fine. And we are having frequent item set generation also. Frequent item set generation. That means uh, that means we are taking the combination of items. We will start with one item, that is single item. We can take two item, we can take three item, and so on. Frequent item set. That means these are the combination of items which are present in your data. Okay, so the frequency is determined on the user defined threshold. So this is a critical parameter. That means how much items one can purchase. For example, if it can purchase max 4, so we can make a combination of 3 3. Okay, that means this threshold is a critical parameter identifying the items that are significant for analysis. Okay, for example, suppose we have a support threshold of 50%. That means that means items like milk and a bread might be considered frequent if it appears 50% or more than the transactions. 50% threshold we have mentioned. So frequent item sets will be considered because you are having four or five types of transactions. You are having four or five transactions in which three times you are having these two. So more than 50 times it appeared. So you can consider this kind of items as a frequent item. Frequent means most recently used, or like no, every time, or I would say mostly. That is called as a frequent. So out of five transactions, if three times you are taking bread and the milk, so obviously it is frequent. But if there is any combination, if it is taken only one time out of five, this is least. This is not frequent. This is least. Okay, fine. So this is your okay algorithm, a priori algorithm, which do find out your what most frequently used item sets. Okay, so in this particular association rule coding, I did the same thing. Okay, I used the group of items, frequent items. I applied a priori algorithm to meet the minimum threshold, and then I returned the data frame of frequent item sets which are used. Okay, fine. So let's first check how I approached. So let us suppose this is my basket. I prepared my basket. In this basket, I am having supplier, year, and month, and this is my item type. I perform group by. That means supplier, year, and month are columns, and I'm grouping them with respect to item type. Okay, so this is a supplier in the month of 1, 2020 year. These are the items. Okay, these are the items. List of items which are sold by this supplier. Then in month of 3, it's supplied again the same items wine. Then in month of 7, it's again supplied the same wine three times. So I am having like all the suppliers. Year is same for every month. What they have supplied, how much number of entries are present in my data. Correspondingly, I have prepared a list of them. This I called as a basket group by. Okay, fine. And then what I did is I applied transition encoder. Why transaction encoder applied? Again, the same thing to convert the list of transactions into a matrix format that can be easily processed by the machine learning algorithm. Transition encoder. Again, here also. Transition encoder is a pre-processing technique to convert a data into a format which can be processed by machine learning algorithm. That means again numerical format. Machine learning algorithm is a mathematical model. It is statistical model. Okay, so there are equations present in it. Unless and until you don't convert the data into numerical, how my machine learning model can convert it? Okay, so I created a basket. The reason is these are the item types which are supplied. So with respect to supplier, year and the month, what are the items? Just make a list of them which are supplied. Okay, here there is no consumer present. Let me tell you very frankly. Here we are having a supplier. So the entire case is different. The phenomena of market basket is depend upon consumer problem. Okay, consumer. What consumer is taking? Actually, right now I'm assuming that I have supplied the products. So ultimately, it is taken by the consumer only. Na? So just keeping supplier here at the priority. Okay, and then I prepared a basket. But basket is prepared for customer. That what items customer take. But here I'm considering supplier. How many items supplier sold? Because this is a sales data and we don't have anything related to the consumer. Okay, we are having the details related to only supplier. Okay, got it. So then I prepared a basket. I perform encoding of the data. Okay, and created data frame of it. So transitional encoder will create a data frame. It will convert your text to numerics. Okay, in a binary representation, it will convert. Okay, fine. And then whatever be the encodings are, you give it to the a priori algorithm to make a frequent data, to make a frequently data sets, item sets. Here you can put the values from your side. Minimum support should be zero point 0.1 because support is what? Support is what? Frequency of x comma y divided by total. That is the support. You can choose a value from your side, whatever be the minimum support is. Okay, so I'm applying a priori to identify the association, to identify the relationship. If I'm purchasing wine, if I'm purchasing here wine, what is the chance that I'm going to purchase alcohol? What is the chance that I'm going to purchase any other item? So that is what I'm looking for. Or I'm here the case is supplying. If I'm supplying wine, whether I'm supplying this alcohol or any other item, that is what kind of relationship I'm trying to identify among the items. So I prepared a basket in which I am available with the items. I am available with the list of items which are sold by the suppliers, and then I'm trying to find the relationship between those items and how what they are in what like relationship they are sold. Okay, it's an approach you are learning. Okay, you can apply it to any other data set also, but the theme will be same. Theme will be same. That's what you can apply. Theme will be same. Okay, fine. So I applied a priori. Yeah. Okay. And these are the frequent item sets I got. Okay, these are the frequent item sets. Okay, that means uh, beer, Dunwich, cakes, liquor, and all these things. Then I got some combination also like cakes and the beer. Okay, if cakes are supplied, then beer is also supplied. Okay, it's present at seven number. Then liquor and the beer. Okay, then beer and non-alcohol, beer and the wine, cakes and the liquor. So these are the relationship. Okay, and this is what at the last wine, then liquor, then beer, and non-alcohol. This is present at the last. Okay, and what here are the support values. The higher support values for the beer. That means mostly it is supplied. Then Dunwich. Okay, it's not been arranged like in I guess it's not been arranged in a descending order. So kindly ignore the words which I told just right now. It's not arranged in a descending order. If it might have been arranged, then wine should come at the top because it is zero point 0.6. It is having the highest support. Okay, so kindly ignore like it's not been present in the descending order. So the highest support is for the wine. The data is related to such kind of products only. So wine is supplied most. Okay, and then we are having other combinations also, which are having less in number, like very less support values, but yes, they are present. So these are the frequent item sets. If someone asks you that, okay, what is purchased, then after that, what is purchased, so you can see, you can tell them. Okay, you can tell them. Okay, these are the combinations. Okay, here is the support for them, that how the items are sold. Okay, fine. And I got the frequent item sets. I applied the association rule over them. Okay, and I got all these values. What is the support? What is the confidence? What is the lift, and so on. What is the antecedent support? What is the consequent support? I just already told you antecedent and the consequent. I already explained. What is the antecedent? What is the consequent? I already told. Okay, fine. So 94 rows and 10 columns are prepared for that. The most important are like antecedents and the consequents, their support values, their confidence values, along with the lift. That's it. Okay. So if kicks is purchased, what is the chance? Or I would say, if cakes is sold, what is the chance that beer is sold? This is the support for separate of them, and this is what I'm having. 0.96, 96% confident that if cakes are sold, beer will be sold, and so on. If beer is sold, cakes is sold, here is the confidence. 0.50, only 50% confidence. Beer and non-alcohol. That means only 9% confidence. So these are the combinations, okay, which are being prepared by the rules. We can sort them with the help of a lift. Okay, we can sort them with the help of a lift, and that is the sorted data frame. Okay, this is the sorted data frame. So I just want to find the association in this particular data. I applied only one algorithm that is useful, mostly used, that is the a priori algorithm, just to find the association roots. Okay, however, this is not a customer data. This is a supplier data. This is retail sales data. This is warehouse sales data. So you can follow this approach to apply over the customer data also. Okay, related to the purchasing. Okay, fine. Now the next thing is one more technique, that is the deep learning I applied. Now I'm just going very separate. Machine learning regression I applied. Unsupervised learning k-means I applied. Association rule also I applied, and deep learning also I'm applying here. Okay, deep learning, again the theme is to find the regression, to perform the regression. Okay, to perform the regression only. I did regression analysis with linear regression and rest of the machine learning algorithms, but with deep learning, I'm looking forward at whether I can improve the results or not. There are any chance that I can improve the results or not. So what happens in a deep learning is you are having a neural network. You are having the neurons present over the layers. Okay, you are going to give the data to these layers in the neurons, and then this neuron will be like a feed forward network. This will behave like a feed forward network, and here I'm going to get one answer. Okay, one answer I'm going to get it here. So I think this is a better approach, deep learning, rather than machine learning regression. Okay, so what I did is here I took sequential model, dense layer, optimizer as an atom. The framework I'm taking here is a TensorFlow. Okay, so TensorFlow is a deep learning framework. Okay, and we uses mostly two kind of framework. That is, one is the TensorFlow, another is the PyTorch. Here I'm taking the TensorFlow. Okay, and model I'm taking sequential. The one which you are seeing here, no, is sequential here. This is sequential only. Okay, this is sequential only. Sequential means, okay, feed forward. Sequential model. You are arranging the layer one by one. Okay, and these are, if this is input layer, this will be like output layer, and we are having intermediate layers. They are also called as hidden layers, or they are also called as dense layers. So mostly the computation has been done on dense layers only, or hidden layers only. The computation is done here only. Okay, and again you took your df data frame. Df only you took, df1. Okay, supplier and item, categorical, rest are the numerical. Okay, you are applying this thing. Again, same column transformer you applied. So converted categorical into like one hot encoding, rest numerical, you converted you perform the scaling. Now again, one thing, mandatory. Okay, this is mandatory. The mandatory thing is, for deep learning you have to perform standard scaler. Okay, for deep learning you have to perform standard scaler, a requirement. Just like in linear regression, no, you applied log transformation. Similarly, for deep learning, you have to use standard scaler to scale the data, because you may have some values which are high, you may have some values which are low. You have to scale them, and the formula for standard scaler is x minus nu upon sigma. This is the formula for standard scaler. Okay, so it's kind of a like normalization. It's kind of a transformation only. It's a scaled transformation. Okay, one more thing I got to remember related in K means also, which I applied. In K means also, this unsupervised clustering algorithm, because it is a distance based algorithm, remember, this is also distance based, this is distance based algorithm. So in this distance based algorithm, few things which are required is remove outlier from data. Remove outliers from data. This is required. And in K means also, if you can scale your data, that is also good idea. Scaling, just like here only, standard scaler you took. Similarly, in unsupervised, this K means you can do. That is also a better approach, because K means is a distance based algorithm. So standard scaler is feasible. So remove the outlier, use the scaling technique, and then apply it into the K means algorithm. However, in my code, I haven't applied that thing. Okay, I just performed the transformation like one hot encoding. Okay, maybe let me check. Did I apply it? Did I told you this thing here? If I applied, then it is okay. Okay, fine. Here it is. Yeah. Okay. Mm, yes, I did. I did this thing. So it's like now we have to scale your data for distance-based algorithms. One more thing, outlier removal, but from throughout the code now I haven't applied any. I haven't removed any of the outlier from the data. Let it be. So these are the two requirements. Okay, in deep learning, okay, you are doing one hot encoding, fine. You have to apply standard scaler. Okay, that's what you have to do in deep learning also. Okay, fine. Retail sales is a target, so drop it from X, take it to Y. One more thing, I scaled I scaled retail sales also. इसका भी स्केलिंग करा है मैंने, क्योंकि ये भी जो है दिस इज ऑल्सो कंटिन्यूस इन नेचर. सो ये जो फीचर्स हैं, द फीचर्स एक्स, आई डिड स्केलिंग फॉर देम, बट I scaled target also. Why? Because that is also continuous in nature. Okay, and then I converted it into 2D, reshape kara also. So I scaled this thing also. Why? In the previous example, when I was using support vector regressor, K means also, I haven't scaled Y. That is the note which you should take. Note it. Note it. That Y, which is a retail sales, that is continuous. That was not scaled previously. But you can do it. You can do it. And check. I hope there will be a change in answer. Possibly, it may happen that you may get better answer. Better answer. Okay, try. Scale Y also in SVR and K means also. Do it. I haven't done. You can. Okay, just take copy this code and paste it there. That's it. Okay, so I scaled my Y also. I trained test split it, and this is the model I created. This is the architecture I created. Very simple architecture. I took model sequential. I took three dense layer. Three layers I took. In one layer I took 64 neurons, one layer I took 32 neurons, one layer I took only one neuron, because this is the output. Okay, so my architecture is like this. Okay, only like this. 64 neuron, 32 neuron, 1 neuron. So 64, 32, only one. Why I took one? Because this is linear regression, I am going to get one output. Rest all the inputs. How many? 301. What is the size of your input? Okay, just take 300, because X are 300, Y you separated. Na? So 300 inputs, 64 neurons. So all 300 will be distributed to all 64. Then whatever be the output come, then will be distributed to 32. And finally, they will be all given to only one. And what is the operation which we do at the deep learning layers? Y equal to Wx plus B. So X is your input. W and B are the weight and the bias. They are automatically taken. ना आपको नहीं देना. And then we have to give the output which are getting here Y, that is given to activation function. And the activation which function which I am taking here is ReLU, that is rectified linear unit. In general, we do take ReLU for such kind of problems. This ReLU activation function, this is a non-linear activation function. Non-linear because I want to capture non-linear relationship in the data. So this is non-linear activation function. Its value is 0 if the input is 0, and its value is same if the input is greater than 0. So if the value is less than 0, output is 0. If the value is greater than 0, so output is same value only. For example, if input is minus 10, output is 0. If input is plus 10, output is 10. That is ReLU. Okay, so I use ReLU activation function, and all this is the architecture I made. I compiled my model to configure it. Obviously, mean square error is the criteria which I am going to look out for. Regression है ना ये. Mean square error is the criteria. I iterated my model for 100 epochs. 100 times I trained my model. Okay, I iterated my model for 100 times. Okay, and I got good score then. My error got reduced. Okay, my error got reduced. Okay, fine. So after training my model, I evaluated my model, and here is what I got. These are the losses I got. The mean absolute error is 0.17. That is very less than the machine learning models. Okay, that are very less than the machine learning models. So I think I am in a better position in deep learning model. Okay, fine. And then what I did, I need to have a plot for the loss. This is the loss plot. How my training goes till 100 iterations, 100 epochs, and what is the loss. So this is the training loss, and this is the validation loss. And this is fine. Validation loss should have to be less than the training only. So as my training goes on, my loss is getting less and less. My validation loss is like also this. Okay, fine. So this is what I predicted from the trained model. I performed the inverse transformation of it because you scaled na, your data. So you need to perform inverse transformation of your data. Okay, fine. And this is your original test. So predicted and original. These two you took ahead to make a plot, final plot. That is a regression. This is your predicted. Okay, blue are predicted and red is the original line, and this is blue is your predicted. Okay, so here I evaluated my model. This you can see. This is my model evaluation. Okay, and this is my the regression line, predicted versus actual. This is my regression line. Okay, so this is the good fit line. However, you can see that how points are coming here. Okay, it doesn't matter. The variance is well explained. Okay, and yes, as already seen in the training that we are having very less error, and error is the main concern. If the error is less, that means we are having the points. Okay, we are having the points which are in a good space, good location. Okay, and we are having good fit line. Okay, you can modify the architecture also. It can be modified. I took only very small, very less architecture, like very few layers. जैसा data था accordingly I took. Okay, so here deep learning is also applied, and I got this result. So I applied machine learning, I applied unsupervised clustering and association both. Along with that, I applied deep learning. This ends my project number two. Yes, yes. Anything to say? Yes, anything you want to say here? I applied all these algorithms on the retail price. Data was very challenging. Very few features are available. We have to self-define the scope. What can be done? Okay, so we took a challenge that okay, we are available with the less features. So let's apply a regression. Take retail sales as a target, and whatever we are available, just apply the regression. Okay, we got some success also with linear regression. Here with the deep learning, also I got success. Okay, that means error is very less. I am able to predict the results. Okay, fine. And then we proceeded for the unsupervised algorithms. Okay, in unsupervised, we tried to cluster the data using k means. That's what we tried to identify the groups. We got two optimal at position number two and somewhat at position number seven. I got two optimals. However, I picked this two and told that there are two cluster feasible. So my k means is over. I divided the data into two clusters. Apart from that, in order to plot, I applied PCA, principal component analysis, to take the two components and put up the data on these two components which are having highest information. That's what I did. Then association is something just a plus point, a algorithm which I use additional. Okay, just to help you in understanding that how you can apply rules for market basket. That means you are having items, you are having the features related to it. Make a basket. Okay, prepare a basket. Then try to identify the frequent item sets. Frequent item. Give it to the a priori algorithm. Okay, and then identify all the details, confidence, support, lift, everything. That's what you have to do, and try to find which item is selected, then which item is selected, then which item is selected. So this is market basket. All right, so we have came so far here, and we are done with the two projects. It is mandatory for you all to run the projects, to execute, to work over this codes, this data, and if possible, you can also publish your result. I have seen none of them has so far shared your outcomes, your results, your possibilities. I don't know why.